Neal Koblitz is a professor of mathematics at the University of Washington, as well as an adjunct professor at the Center for Applied Cryptographic Research at the University of Waterloo. Koblitz received his undergraduate degree from Harvard University and received his PhD from Princeton University under Nicholas Katz. He is a world-renowned mathematician, best known for having co-created elliptic curve cryptography, or ECC, in 1985, a technology that underpins many of the information systems that exist today, including Bitcoin and Ethereum. He was recently awarded the Levchin Prize in Real World Cryptography in 2021 for his work on ECC. He, along with his wife, run the Kovalevskaia Fund, a foundation that encourages and aids women in science and technology in developing countries. Thanks for taking the time to talk today, Professor.
Thank you. Thank you for your generous introduction.
I would love to start with your early life. So you were born in the U.S., kind of went to India for a few years, then returned back to the U.S. and kind of upstate New York. How did those 3 years in India, kind of a developing country, affect your worldview, motivations, and work ethic?
Well, it was actually 1 year, but it was a very sort of important year for me because I was just at an age, I was very young, I was like 6 years old, but I was old enough to see the extremes of poverty in India, which I wasn't used to seeing, and had a big effect on me because I couldn't sort of rationalize it away. I couldn't understand it, and that affected my political activity later on, and in a way, my sort of progressive politics or leftist politics, whatever you want to call it, dates back that far. And so does my interest in mathematics, because the school I went to in India, which was a Catholic school, quite strict, and it had good academic standards. And so I learned more math there than I would have back in my school in the US. So when I came back, my teachers erroneously thought that I must be smart because I could do things that the other kids couldn't do. But of course, it was just because I'd had a very productive year in India learning a lot of math, for that age. And so she sent me up to. I was in the third grade. She sent me up to get the fifth grade textbook because I was so advanced. And of course, that type of encouragement can help send you in the direction of a career in mathematics.
Hmm. So should we try to emulate more aspects of that Catholic school in India? Were you working harder there, or are there any characteristics that can be transferred into like a more American education system?
Well, I think sometimes old-fashioned type teachers are not appreciated these days. But they can be very good. I think different teaching techniques can work for different teachers, and I've been involved, helping out in various. I used to teach a course for several years for math majors who want to go into high school teaching, and we went down to some middle schools, and middle and high school teaching, and we went to some middle schools downtown that where we helped work with teachers and sort of presented math enrichment material to the kids, and that was really interesting. We learned a whole lot. We might have learned more than the kids did from the experience, and it was one thing that I got to appreciate was that sometimes sort of strict teachers who were not like modern, up to date, sort of the trendy things could be very good because they could provide uh, some structure and stability and firmness with the kids that the kids actually responded well to. And I think there's sort of a myth that if you're tough, it's bad for the kids. But such a thing as tough love, and I think, at least in my case, the teachers who I'm most grateful for were pretty tough, and that's why I learned more from them. So maybe that's a sort of old-fashioned attitude, but I think um, often in other cultures you find in third world countries and uh, uh, other parts of the world, non-Western parts of the world, you find uh, that there's more of an appreciation for education. That is sort of the way ahead, social mobility and improving the country and so on. It really depends on education. People appreciate it more. They're willing to work really hard. They go to tremendous sacrifice for their kids to get a good education. And I think America has a lot to learn from other countries.
For sure, for sure. Um, yeah, so kind of reading over like your blog posts and parts of your autobiography, it seems like you are very economics driven actually, like frequently thinking in expected value terms and constantly thinking of ways to kind of increase your leverage. Kind of according to your autobiography, you realized from a young age that you would never be the best at math, you would never be the best at Russian, but you could perhaps kind of be the best at both. Like how else have you thought about kind of ways to increase leverage in your life?
Well, the way I would put it is, I think whatever somebody's ideals are, if they want to be effective, they've got to be pragmatic and realistic. And uh, um, you can't do everything, and you can't. And sometimes sort of symbolic things really aren't worth that much. People get really overexcited about things that really are not of that great practical importance, and they debate things that are really kind of uh, much less important than other things that could be done. And so I don't know, you could call that economic, or you could just call it pragmatism. That um, I think a lot of times these days, when people uh, talk about what they see as progressive politics, a lot of cases it's not really doing anything. It's just sort of getting all excited about what words one uses, or what official statements one puts out, acknowledging this or acknowledging that, or endorsing this slogan or that slogan. But very often, people who are doing the most radical things, or the most important things that are progressive, are not being so noisy about it, but are sort of working on some concrete project. And I respect that a lot. And um, I'm not nearly as committed to that as many people I know, but, but when I do get involved in something, I try to make it something pragmatic.
Why is it, do you think, that the Soviet Union and more broadly Eastern Europe has been the home of many great number theorists and cryptographers?
Well, I think there are a couple reasons. Uh, Russia, even though in many ways was a backward country in the 19th century, in the Tsarist period, but even then they had some really impressive intellectuals who aren't as well known in the West as people like Darwin and so on. But some of the people like Kropotkin and Kovalevsky, the husband of Sofia Kovalevskaia, and many others whose names don't come to mind right now, Menshnikov, and there's just a whole bunch of really top scientists over there, even in the 19th century. And then in the Soviet period, there was tremendous government support for the sciences. And they saw it, it was actually on both sides. So in the US, there was much more support for education and much more of an impetus to improve things during the Cold War period, during the space race, for example, back in the 1960s when I was a little kid. And we were all just so excited about the first trips into space, and of course the Soviet Union did it first with the Sputnik in 1957, and that really shocked people in the U.S. because it showed that they were not really so far behind the U.S. in what they could accomplish. In some ways, were ahead, and this shocked people, and so people talked about the Sputnik era, where there was a big impetus to train teachers better, to have special programs. I went to an NSF supported, a government supported summer program for high school students at what was then called San Diego State College. It's the only time when I was a kid that I came out to the West Coast, but I spent the summer there, and it was very helpful. And so did many people in those days. So there was a big enthusiasm about education, not only in the Soviet Union but also in the U.S. And it was partly motivated by Cold War competition. To be the first on the moon or the first to do first into orbit. Um, and the Americans won some of these, and Soviets won others. They were the first into orbit. The U.S. was first to the moon, so on. So, whether that was really that important or not is another question, but it had the symbolic value, and it was supported by both governments, partly for reasons of, or largely for reasons of prestige and sort of power, just the sort of this rivalry between the two countries. But it also meant that it was kind of something that always interested me, that the scientists and mathematicians had tremendous respect for each other. It was not really rivalry so much as wanting to uh, have more contact with one another, to keep to prevent the Cold War from standing in the way of scientific cooperation, collaboration. And so for me, I had a wonderful time over there, and um, and the Soviet government was very friendly toward visiting scientists, by and large, as long as as long as we didn't do anything to anger them. They did not regard us the way they regarded American diplomats, for example, or American journalists, who they didn't trust, any of them, but probably for good reason. But the academic people, the scientists were treated well. I mean, uh, and of course the Soviet scientists were very glad to see us and talk with us. And then there was some really thrilling experience, or very weird experiences anyway. Like in 1985, I gave a talk at the Moscow Math Society. It was very unusual to have an American speak there. But the really weird thing was that my topic was cryptography. I had just become interested in cryptography then, just about a year before. So I didn't know a whole lot about it. But in the Soviet Union, there was no open work in cryptography at that time, no open research. It was all secret, it was government controlled. And so nobody had ever given a talk about it before. And a friend of mine, a mathematician, said, "So what? If that's what you're working on, why don't you talk about it?" And he thought it would be actually very funny to have the first talk on cryptography ever given at the Moscow Math Society given by an American of all people. So because this was this top secret thing, and of course I didn't know any secrets, but much later I talked to someone after the collapse of the Soviet Union. This was about 2000 when I met someone who's quite a prominent researcher in cryptography, who at that time, 1985, was part of the KGB, which is the equivalent of the NSA here, and and he said he went to my talk, on behalf of the KGB, just to see what this American was going to say. And I said, well, it was probably very boring for you because, at that time, I really didn't know that much cryptography, or at least, I knew somewhat about the purely mathematical part of it, but nothing practical that would be of interest to the KGB. And he said, no, there was actually one thing toward the end of your talk, which we did learn from. And it was something that was fairly well known in American cryptographic circles and very openly known. But apparently the Russians hadn't really for some reason didn't know about this. And that was how you could use public key cryptography, which was still pretty new. It was about 10 years old then, to set up a system of where two mutually mistrustful countries, superpowers in this case, could install nuclear test detection devices, like they use for earthquakes, seismographs of some sort, um, on the other one's territory in such a way that they could trust the data that they get from it, and yet the country where these devices were planted would be able to verify that nothing was going out of the machines that was not supposed to. In other words, they weren't being used for spying. So it was a way to use public key cryptography to have the U.S. and the Soviet Union verify each other's adherence to nuclear test ban treaties. And it was just something that I'd heard because a prominent American cryptographer at the time, Gus Simmons, had proposed this just as a thought experiment. That see, this is one thing that sort of that you don't usually think of that public key cryptography can do. And I mentioned this in my talk because I thought it would be a cool way to end a talk in the Soviet Union, giving a way that cryptography could be used to strengthen mutual trust in the area of test-ban verification. Because it's easier to agree on a treaty if you know you can verify that the other side is adhering to it. So it's a positive thing. It's not spy versus spy, but so this guy who had been in the KGB at the time said he had known about that. So I said that was pretty cool. So there was something of value in my talk after all, other than very sort of elementary basic things. But it was really for me at the time, it was the talk I've been most nervous about ever, because all the leading mathematicians most of the leading mathematicians in Moscow went to the weekly meetings of the Moscow Math Society, and so to give a talk there, you knew there'd be all sorts of very well-known people in attendance, and so you didn't want to mess up. And also, I gave it in Russian, which I knew pretty well then, but I had to rehearse it very well, because I wasn't completely fluent, but I certainly knew enough to talk about mathematics. But then, of course, cryptography involved other things besides mathematics, so I had to be careful and talk to some people in advance who gave me advice on how to give a good talk and this sort of thing. So it was really an exciting but sort of nerve-wracking experience to give that sort of talk. And that was just one of the first things I did in cryptography. I mean, the first talk I ever gave probably in cryptography was at the Moscow Math Society, which is also sort of bizarre. I certainly was not an expert at that time.
On the topic of cryptography, kind of more recently in 2014, the Ethereum Foundation kind of announced a partnership between yourself to bring you on as a cryptographic advisor to the Ethereum project. Can you describe your work with Ethereum Foundation, and what did you think of Ethereum at the time?
Well, I had a lot of respect for Vitaly Buterin, who started it all. My collaborator in a lot of my recent publications, named Alfred Menezes, he's a professor at the University of Waterloo. In fact, he's visiting Seattle right now. We often sort of get together or at least collaborate online. And Buterin is actually a student in his class, so he knows him personally. I've never met him in person, but I've had an email with him during this period. It was just really for a few months, and it was before Ethereum even went public. I think it went public maybe in the middle of 2014 and 2015. It was
Something like that, yeah.
It was a few months before they went public, and so I was a sort of consultant. I had email. As I remember, I just gave some sort of advice to Vitalik on a couple issues that he knew that I knew something about. So, like, I guess there were some rumors that the elliptic curve used in Bitcoin for the elliptic curve discrete signature algorithm. Some people were questioning whether it was secure, or they were sent, or maybe they were. There was also the period of time. I'm not sure exactly what the issue was, but it could have been related to the Edward Snowden revelations, where it became clear that the NSA put in a backdoor into an elliptic curve version of a random bit generator. And this was a big scandal, and was just horrible news for people working in cryptography that NSA had successfully sabotaged a standard for cryptography that then they also basically bribed RSA to put it as a default in the Be Safe kit. And that whole story really sordid. It was really unethical by NSA to do that, and caused a lot of mistrust toward NSA. But it also caused skepticism about certain types of use of elliptic curves as well. Some people were saying, well, how do we know that They didn't put backdoor and other types of use of elliptic curves. I mean, if you know the details of how these systems work, you can see that there is a big difference between the bit generator and other uses of elliptic curves. So, and in fact, even the designers of the of the random bit generator knew that it could be backdoored and had warned about it, but the warning was not widely publicized and was not paid attention to. And nobody thought that, I guess, nobody thought that it was actually going to be done. It was just sort of a theoretical possibility. But it's also very easy to avoid that any backdoor if you're careful. But people were not careful at that time. And the Snowden revelations basically made it clear that there had been a backdoor. Um, and and so there were questions being raised about either elliptic curve use, elliptic curve cryptography in general, or certain specific curves. And I basically reassured him that there was nothing particularly uh, risky about the Bitcoin elliptic curve. And if he wanted to use something similar for Ethereum, that I didn't think there was any valid reason to say you should choose a different elliptic curve. So I remember giving advice on that. And also, the other thing was that there was talk even then about how proof of work is very bad for the environment, and it also gives a bad public image to cryptocurrency. Something that's socially harmful. And I said that I thought this was a big issue, aside from the environment, which is, of course, important to care about. But just from the standpoint, just the self-interest of Ethereum, I thought it was important to move to either. Well, I wasn't thinking of proof of stake. What I was thinking of, which turned out not to be realistic, and probably a stupid idea. But what I was thinking of was finding a way to do some work that to do computation that really needed to be done that would be like scientifically useful. Like there are various projects that you probably know, to harness the public's computing power to do various things like mapping the sky or folding proteins or looking for dangerous asteroids or whatever it is. There's certain areas where so much computation has to be done that could be useful to just have millions of people with the idle time, using the idle time on their own computer to help. And I even talked to somebody in the astronomy department at my university about this, about these some project that he was involved in, some sky mapping project. But certainly, I couldn't think of any practical way to do it because the way that this is normally done, a proof of work, by this vast repetition of applying hash functions until you get an output that starts with a whole lot of zeros. Um, the thing is about that it's very predictable how long it's going to take, and it's also if you succeed, it can be verified immediately. That once you have the input to the hash function and produce all these zeros, anybody can tell that you did it. So it's a very efficient way to do this proof of work. But it's also completely useless and burns up a huge amount of energy. So at the time, I was, actively thinking of how you could do a proof of work where the work really was something useful. That's what I thought. I did not think of proof of stake, and I haven't worked on proof of stake, although it's a little risky to shift to something that's hasn't been time tested. So who knows? But but probably the idea that I was hoping for was completely impossible, or at least nobody would know how to do something that would fit into would have all the features that you need for proof of work, and yet would be beneficial scientifically. So that was just an idea I had that didn't go anywhere. But later on, they I didn't have any real direct involvement with them. I briefly talked with this guy who split off from Ethereum to start what they call Cardano or something.
Yeah, Charles
Another,
Hoskinson.
yes, yeah. He contacted me, and he has math background, so he
Hmm.
talked with me for a while. But and I went to some video meeting with them and everything, but that never led to anything. So I haven't been in touch with Ethereum since about 2015, but I've heard a little. I followed a little bit. Uh, Buterin was recently interviewed at some length by the New York Times, and I listened to that. He's a very articulate guy, extremely smart, and um, and so I've had a high opinion of Ethereum relative to other um, all these other cryptocurrencies that sprung up. Um, and he had a really original. There was something fundamentally original about it, that this idea of smart contracts done on a blockchain was really a very clever idea. As far as I know, he was the first person, maybe not the first person to think of it, but the first person to really try to implement it and to implement it successfully, basically. And I thought it was a fascinating idea, to do that, to and that was the start of putting other things on the blockchain other than cryptocurrency. As far as I know, he was the first to really go big with an idea for something that was not primarily cryptocurrency on the blockchain. So it was impressive. He's a very sort of thoughtful guy, and he's also pretty modest. I mean, he doesn't come off as being the least bit arrogant or self-promoting, or you know, which is also kind of unusual in the high-tech world, in my observation.
Yeah, I think I was able to talk to him for a little bit at the Stanford conference a few months back, and he's definitely a very humble, very
Yeah,
intelligent guy, for sure.
yeah, yeah.
Um, you've written a lot and been vocal about the U.S. Vietnam relationship, kind of particularly on kind of university governance structures and kind of corruption across U.S. higher education. What are
Mhm.
some kind of easy, low-hanging fruit actions that schools can take to decrease administrative bloat and better align interests?
Okay, well, that's difficult because bureaucracy has become entrenched. It's sort of like asking what can be done to trim certain things in the government or in the military, especially. And uh, I think it's good to try to reduce the power of the administration, because the more powerful it is, the more it grows, the more it increases its resources as opposed to students and faculty. Uh, and uh, there are a lot of stereotypes about other countries being so bureaucratic. But in my observation, the uh, U.S. universities are the most bureaucratic universities in the world. And that's not necessarily their fault, because they're just more universities are expected to do all sorts of things that universities are not expected to do in other countries. And they have all sorts of offices. They're supposed to take care of students' psychological problems. They're supposed to have all sorts of sort of government relations things and offices for just anything you could think of to promote ties with industry, everything. And a lot of things that are totally useless, just churning out paper. And uh, even the Soviets, who were known to be very bureaucratic, didn't have anything like that in their university system. And like when I wrote an article about this, talking about um, uh, or one of the things I talked about in my article, criticizing American so-called advisors to Vietnam in the area of higher education. Basically, I said that we're not a good model for any country, least of all a country in a relatively poor country, because they can't afford a bloated bureaucracy such as we have. And in the course of my article, I used the term provost, which is a standard term in the US for someone who's just underneath the president of the university. And my colleague and friend in Vietnam who's translating this article into Vietnamese for me told me later that he had to invent a word in Vietnamese for it because there's no word in Vietnamese for that level of bureaucracy. They just don't have that many levels. So he translated something that roughly means super dean, like a dean but a super dean, or supervisor dean, or something like that in Vietnamese. And the Vietnamese are used to sort of inventing words to correspond to things that pop up in the West. But that was like a symbol for me of how uh, Vietnam, although it has some problems with bureaucracy, but they can't compete with the U.S. as far as bureaucracy at the university level. But I think if it becomes harder with time at the faculty level, partly because an awful lot of faculty now are contingent faculty, that is, they're adjuncts or temporary people, or they're hired in purely teaching positions, not research positions, where they have a very high teaching load and in some cases don't have much job security. So they're not in much position, generally not unionized, not organized. So in the research cadre are getting smaller, so faculty power is not going up. So power is sort of gradually shifting. And I don't think students have much power either. So that makes it hard to deal with, when the administration's entrenched like that. But I think we should at least be aware of the problem, and we should certainly not be holding our university system up as a model for other countries. Sometimes in these countries, there's a sort of misunderstanding because they know about all sorts of impressive accomplishments out of the U.S. and they know the U.S. dominates many fields of technology and science and gets a huge proportion of the Nobel Prizes in scientific fields and so on. But they somehow think that must mean that everything about education in universities in the U.S. must be really a great model to follow. And and one of the things that I think is useful for Americans like me to do when we travel around is to disabuse people in other countries of that. Talk a little bit about the downside of education in the U.S. and tell them things that are really shocking because they never imagined go on in the U.S. And like little vignettes, little stories can sometimes really shock people in other countries if they've never been to the U.S. about it, like um, um, something like a calculus student, and many years ago, complained about me because on an exam, like a midterm in calculus, I assumed they knew the formula for the area of the circle. I didn't give it to them on the exam. And just about anywhere else, I said, "What? They're a university student taking first year calculus, and they're complaining because you assume they know the area of the circle." In America, they just wouldn't. It'd be very hard for them to digest that information. That could happen in America. And there are many stories like that. When I was visiting Cuba, I showed a film that was made in the 1990s, sort of based on a study comparing U.S., Japanese, and German high school and middle school level math. And the most interesting part was a video showing like a typical eighth grade class in the U.S. and in Japan. And I'd spoken in Cuba about the deficiencies in American education, which they knew nothing about. They're sort of isolated because of the hostility between the two countries. They've never traveled to the U.S. And of course, they very much respect U.S. science. So they probably weren't really sure whether they could believe me. They might have thought I was just complaining about things in the U.S. in education, and really it wasn't so bad. So I showed them this movie because a picture is worth 1,000 words, and I showed them the two classes. Unfortunately, these movies were well done, and they had captions. And the Cubans, their understanding of spoken American English would be pretty poor, but of course the Japanese class had to have captions, but the American class also had captions in English. which was really good because it would be very hard for non-English speakers to understand what's going on between the teacher and the students just from the voice. Uh, and the Cubans were just shocked. Then they no longer wondered about because the Japanese eighth grade class in geometry was far, far superior to the U.S. class. And this was a study done by Americans, by an education researcher at UCLA, was the head investigator of the study. And it came out with results which were quite embarrassing to the U.S., were widely publicized in the 1990s. Um, but the comparison just between those two classes, like about a half hour in each class, was just shocking to mathematicians. I was showing this to Cuban mathematicians. Where the Japanese class was creative, conceptual, great rapport clearly between the teacher and students. It was also clearly not a wealthy school because the physical condition of the room wasn't so good, and the desks and so on. So you could tell the way people were dressed and so on. It was not an elite school, and neither was the American one. But the American one was just, you know, the kids were distracted, not interested. The level was just based on repeating and memorizing and formulas and very little content compared to the Japanese. The Japanese were had the kids solving clever problems and so on. So yeah, I think what happened in Vietnam was a particularly egregious example of Americans sort of arrogantly coming to a country they know very little about and telling them what to do, uh, despite the fact that Americans haven't yet figured out what to do in the area of education. And the Vietnamese have Vietnam, like China and some other countries in the region, have strong traditions in mathematics and related areas. Um, but what they did during the Vietnam War, they maintained their mathematical structure, they maintained their universities, even when they evacuated their universities. Hanoi University was evacuated into the jungle when Hanoi was being bombed by the U.S. Uh, and so it was at a secret location in a jungle about 100 miles north of Hanoi. Uh, I visited there once when I was visiting Hanoi. It was really interesting to see, see this, to hear some of the stories people told. So there's some really magnificent things in the history of mathematics in Vietnam. Uh, so, so I was really bothered by the arrogance of these sort of U.S. university people who went over there, sort of administrators and politicians who thought that they knew better. And in one case, one guy over there who's head of the Fulbright office wrote a really vicious attack on the education ministry of Vietnam based on his own ignorance of the subject. And so I read a reputation of that, and so it became a bit of a bitter controversy. Um, with where the Vietnamese, depending on their own personal take on things, would side with me or side with him. I don't know, sort of uh, a really heated debate. So that happened about, I guess, in 2009 is when my article refuting his article appeared. So that was kind of a really interesting experience. But since I do feel that it's one thing, for example, I only visited China once, just for a week, and former PhD student of mine who was there arranged for me to speak at the to call the normal university, the teachers' university, the education university, and I talked about the problems in American education. And afterwards, a couple of Chinese mathematicians told me that they agreed with what I said. They thought that I was, the view I gave of American education was correct. But many of the Chinese mathematicians had visited the West and even the U.S. And or they were in touch with people who taught in the U.S., and they were very sort of internationally oriented people. But the education bureaucrats in China were not. So their worry was that there is this sort of move in China in the education bureaucracy to sort of imitate U.S. things because they thought that was sort of the modern thing to do. And a lot of the Chinese mathematicians, or at least is what I was told, sort of knew better. They knew much more about the West than these government people did, and didn't have those illusions that China should be modeling its education system after the U.S. And I don't think they really do model it too much after the U.S., but there is a tendency in many countries to, especially people who don't really know that much about the subject, to idealize the U.S. and think that the U.S. They should imitate sort of U.S. ways of doing things, and I don't think this makes sense at all.
Professor, it was a pleasure. Thank you for taking your time today. Really appreciate
Okay,
it.
well, thank you, Ryan. Nice talking with you.
You too.
Best of luck.
Thank you.